G'day, I'm Steve-O and welcome to the Outback Shed. In the first part of this project I machined the hub for a rotating 3-jaw tailstock chuck for my Toolmaster Lathe. In part 2 I'll complete the project and give it a test run. The bearing cups are an interference fit and will need to be pressed into the bearing housings. The bearing cups are 62mm in diameter and I'll use a 62mm press bush to push them in. These are a little smaller in diameter than the nominal size, which will make it easy to remove when their bearings have been pushed into place. The bearing seat's a couple of microns less than the diameter of the bearing. This is a 30-ton press and it doesn't label when pushing the bearings in, but it does let me know when the bearing cup is fully seated. That's both cups seated. Now I'll make the axle. I'll cut a piece off some 50mm 1045 bar stock. I've changed the chuck and mounted a small 3-jaw. This will do fine for roughing the bar to a few millimetres over size. I'm going to use 10mm socket head cap screws to secure the end caps. I'll drill the holes 30mm deep. Turning the bar around, I'll rough down the end for the Morse taper. I think I made enough comments about swarf in the last video, so I'll just say, well, that's interesting. Many viewers provided good advice on getting better swarf. This machining was done prior to the release of that video, so I'll do some testing before the next machining project. I did plan on cutting the taper and finishing the axle between centres on the Colchester, so I have a taper turner on that lathe. But the carrier won't fit the drive plate, and as I don't yet have a drive plate for the Toolmaster, I'll need to find another way. So I'll cut the taper with the compound slide. I'll set up a centre in the 3-jaw. I thought I'd need a 4-jaw for this, but this 3-jaw is surprisingly accurate. To set the taper, I'll use this 4 Morse taper arbor and set the compound with a dial indicator. I think this arbor may be sip tooling. Yep, that's about as good as I can get it. I'm not going to put a tang on this Morse taper. I'll leave the end with a reduced round like a live centre. A tang is used on tapers that support a cutting force, whereas this is a rotating chuck. It doesn't transmit drive or need a tang to support a cutting force. Test fit, and there's still some metal to remove, but the taper does feel fine. I guess in hindsight I could have used the faceplate on the Colchester to pick up the drive of the carrier, but I've committed to this method now, so that's what I'm going to do. Now for some bearing blue. I would normally use a lead pencil and do a smudge test, but that doesn't show up enough on camera, so I'll use the messy stuff instead. I'll put a decent coat on the taper and then test fit with the sleeve. I'll then clean off the taper with isopropyl alcohol and retest with the sleeve and see what transfers back to the arbor. There's full coverage of the blue, and the fit both looks and feels good. Next is the retaining cap. The first blank I cut for the arbor turned out to be a little too short, but will do nicely for retaining caps on the preload spaces. The recess is to be 5mm deep with a 10mm hole through. The recess is to allow the cap to locate onto the axle and not just act as a heavy washer. This also provides a surface for the seal to run on. I need to cut a relief for the cap screw head, so I use the Colchester. I have a 160mm 6-jaw chuck I picked up for a little under $300. It's a really nice chuck. It came with a D4 backplate, but I did need to make a D3 plate to fit this lathe. It's a nice chuck and I'm very happy with it. I'll use a 16mm slot drill to cut the relief, then a small chamfer to finish it off. The preload spacers are cut from the same piece of steel and are made oversized, as they will need to be individually fitted to each chuck setup. I'll draw them out and bring them to size with a boring bar. With the taper done, I'll centre a sleeve in the forejaw. I've put some gasket material around it to protect the sleeve. I'll just dial it in as normal. I'll start by machining the seal runner down to 40mm, then machine the bearing mount to 35. I have the sleeve set up in the forejaw and I can use this as a fixture to fit the bearings. First, I'll screw on the end cap and nip it up to make sure it has the capacity to load the bearings. I'll remove the front bearing and insert the spacer, then reinstall the end cap. First measurement shows that the spacer needs to be reduced by a considerable amount. Better to be looking at it rather than for it. Back to the Colchester to remove some of the excess. The 6-jaw chuck is perfect for this as there's minimal risk of distorting the part. Another test fit and the stall mortar remove. Back to the Colchester. I've been aligning the parts for the drill chuck and that works just fine. Third check and it's getting closer. I'm just sneaking up on it. Don't want to overshoot. I moved the camera as the lighting was putting glare on the indicator. The float's now down to a 10, so I'll break out the wet and dry. A quick check with a micrometer to verify it's parallel and back into it. Now feels like it's getting close. Another session with the wet and dry and the plays under 2 100s. I'm going to call it at that. I'll grease the bearings and assemble the unit. I can run it for a while and then reassess. If I need to tighten it up later, I can still do that. Next, the seals need to be fitted. I'll pack them with grease before installing them in the flange. This is the first time using this camera mount and placing was not the best. Apologies for that, but at least I'm not kicking a tripod over. I started fitting the seal with a hammer and block. It got it started, but I finished off with the arbor press. Back in the tailstock, I can make some final assessments. The run out's down to about 100. I'll set up a 1 metre length of 65mm 4140. I did consider using 200mm chucks for this project, but decided on 160s as my tailstock is a 4 Morse and not a 5. A 200 would fit comfortably over the cross slide, but I'm happy with the smaller chucks. They'll certainly handle any work I could ask of them. Well, not all went to plan, and there are a few lessons learned along the way. I wanted to turn the axles between centres in the Colchester, and in hindsight I could have used a faceplate to transfer the drive to the carrier. Getting the spacer to size on the lathe and with abrasives, although it worked, was not something I'd want to repeat. Next time I want to do a job like that, I'll set it up in the grinder and bring it to size with more precision. There was a lot of sanding I didn't show. I thought I would spare you that. I could have made installing the seals better and easier by making custom tooling for the overpress. That would have made an interesting side project. Well, I've enjoyed this build and I'm very happy with the result. Not sure how much use they'll get, but they're now available when I need them. Again, a big shout out to all those who have built tailstock chucks and provided the inspiration for this build, particularly Matty, Curtis and most of all Max. Again, I'll put links to their videos in the description. Well, if you've made it this far, a big thanks from me. I hope you liked this video. Don't forget to subscribe and give it a thumbs up, and thanks for watching. Be productive, be creative, but most importantly, be safe in your shed. I'll catch you next time.